Hey everyone, my name is Anay Pant, and this is my presentation on Flappy Bird AI. So, what's the goal of this? Well, hopefully, a lot of you know what Flappy Bird is. It's basically a mobile app, which is a game where you control this bird, and your goal is to fly through a bunch of different pipes or jump through a bunch of different pipes. And so, my goal was to build an artificial intelligence that could play this game because I love playing video games, and this is kind of one of the things that I really like doing. And I worked a lot with AI and Python, so I thought this would be a fun project for me to do and share with everyone. So a bit about the architecture of how I created this project and my basic thinking behind it. So Flappy Bird itself is a really complex game, and I wouldn't be able to necessarily kind of use the App Store, use Google Play to kind of get information from there. So what I did was I created my own game from scratch, which I'll talk about in a bit. And from my own game, I can get a lot of information like the velocity of the bird, different pipe information, which is really helpful for the AI. So what I do is I create a bunch of inputs that I want my AI to use, and then I feed those in, and then my AI, which right now is still a mystery, but I'll describe it in a second, creates a prediction for whether the bird should jump or not. So this prediction is based on a specific model, and the model has a preset. The model itself, the structure is fixed, but the different connections between the model or the weights could be any value. So this is your bog standard neural network model, which has some hidden layers, an input layer, which has the inputs from the game, and then a prediction output layer, which in this case is just a single node, which says if the bird should jump or not. And I'll talk about that in a bit. But yeah, here you can see kind of an example of my game where I just have a bunch of these green pipes, this bird, and then some more information. This is really important. I'll talk about in a bit. And yeah, you can kind of see the score as well, which I'll talk about. So I'm talking about the player. So the player is the bird right here, and their goal is to jump through these pipes. And for each pipe you jump through, you get a certain score. In my game, it's 10, but any 1 point per thing or whatever, it doesn't really matter. All that matters is that score is proportional to the fitness of the bird. So basically, the score that the bird gets will influence basically how the next generations go on. And I forgot to mention, by the way, this is a genetic algorithm function, so it's not supervised learning where we have a fixed data set. It's a genetic algorithm, which I'll talk about in a second. But that score is really important for that. So make sure that if you're doing this, that you tune that really well. And then the other object is the pipes. So the pipes are a top and bottom pipe. They're in charge of moving and blocking the bird. So you have a pipe here, and then these are all just individual pipe objects, and more spawn in at intervals. So they have their own speed and all stuff that you can modify. We'll talk about in a second. And then the UI that I used was just called Pygame, and in this situation, Pygame is just this really helpful library that's really good for making simple games and stuff like this. So I use it to draw everything on the GUI, the screen, the caption, everything. That's this logo right there. But so yeah, it's really helpful. Yeah, and I'm just using object-oriented programming, which makes genetic algorithm function really simple. So I can just call all of the objects like the bird and the pipes, which is pretty simplistic for Python. So I think that's not an overstatement. And then, so now it's talking about some of the very specific, the architecture of the neural network, which is one thing that's really important. But before we get to the neural network, I actually just want to talk about genetic algorithms, and that's kind of something that I was hinting at earlier. So genetic algorithm is essentially a simulation of human evolution or evolution in general, where basically you start with a specific population of something, and then only the strongest survive and kind of move on to create the next generation. It's kind of how humans evolved, how all animals evolved. So kind of trying to replicate that for AI. So basically, how the genetic algorithm works is pretty simple. We create a population of games. So basically, all of these birds are kind of they're all these players, all these birds are going to play the game, and basically, I just assigned random arbitrary scores to each. Sorry about that. But you can see that, let's say that if I'm playing, I got a score of 15, then I'd be part of this population. But the strongest birds here, you can tell, are this bird of 22, 18, 17, and some of the weaker birds, like this guy only got 1. But basically, the strongest birds will pass on to the next generation and kind of keep going so that you can get more stronger and stronger birds. And basically, how you define the score, like I was saying with the score earlier on, is that you feed inputs into an AI, then AI gives an output, and then that output is realized in the game. So basically, this score is a representation of how accurate the AI's model is to complete the game, or to basically keep going in the game. So that this AI has the closest, or has the least error in its model, which means that it has the most likeliness that it will do better. So this AI's structure will be passed on to the next one, as well as these ones. Most probably not these ones. So yeah, this is kind of a representation of the of an artificial intelligence's brain. And then so once you have that, then you have to do, like I said, so that was the selection phase where you have, after the fitness, you select the best parents at, let's say, like these three or whatever, or these four maybe. And then when you do that, then you have crossover, which basically means you take two of the parents, you take two of the random selected, elite parents, and then you take their structures and you kind of mix them, mash them together to create a new structure, which is the offspring. And that's very similar to evolution, where you have two parents creating offspring, and then they pass down their genes. So so then, like, if we just have these two random parent birds, these two parent birds would create a new offspring bird, and then you keep mixing up the parents. So you probably get some duplicates, but not exactly. Sorry about that. So then you create this new population by doing that. One thing that's also very important to note about creating this new population is that you always want to include the older birds, because there is a chance, I don't know how likely it is, but there's a chance that all the new population birds are like trash, or like they're not going to do as good as the older birds, and you don't want to lose that progress you already have. So by putting in these older parent birds already, you're kind of saying that this is a baseline. So if there's anything better than this, that's good. If there's anything worse, you'll still have these guys who still did good. So they'll play the game again. So this new population is made of that. And the last thing that's also important is the population should have a one or two, I don't know, it depends on your population size, but like 10%, 20% of it should be completely new birds, or completely mutated birds, which means that they have a completely structure that's completely different from the parent birds. Sorry. And the reason you want to do that is because you want to minimize the amount of, the local maximum issue, which is that the parents, they may get to a certain point, which is really good, but doing a specific strategy, and you really don't like that strategy. It's not the most optimum strategy. So if you have a newer, completely different AI that finds a newer one, then it may be better, which is always, it's just like that kind of luck. So once you have your new population, then you just go ahead and repeat and do the same thing. You keep going, and eventually you'll get a really strong group of birds, which can probably play this game better than any human can, which is really cool. Now, talking about the AI structure, which is kind of the meat of this project, which is creating a neural network, which is it's not a full deep neural network, because it does not involve backpropagation, which is finding out the error and doing supervised correction, but it is kind of still correlates to how strong and powerful the weights are. Sorry about that. So this is kind of what the neural network model would look like. So you have an input layer, a hidden layer, and then an output layer. And you can have a certain number of hidden layers. It doesn't just have to be one. But the input layer would consist of input that the game is giving into the AI. So that could be things like bird velocity, distance center of pipe, the Y value of the bird, the distance, vertical distance to the pipe, whatever. You could try different inputs. I think I have 3. I don't know what the last one is, but I can take a look at that. But you can also see it in the code on my GitHub, which I'll talk about in a bit. Then it goes into this hidden layer, which does some mysterious things. And then it goes to this output layer, which is to jump or not. And I really want to talk about, the hidden layer and the output layer. So all of these different arrows are the actual weights, and that's kind of what is randomly generated. So these weights are actually changing the functions in the brain. And then this hidden layer and output layer have their own activations, with the output layer's activations being a sigmoid function. And basically an activation function is kind of a representation of that value in a different scale. So this activation function could be something really common like ReLU, which is just a positive or 0. So it's just like a straight line and then positive if it is above 0, or softmax or tanh. So there's a bunch of different ones you can look on online. Most common is ReLU, and then it's sigmoid function. So the sigmoid function is right here, 1 over 1 plus e to the negative x for any x. And that basically gives you this S curve, which is going from going from 0 to 1. So any value on this, any x value will give you a y value of 0 to 1. And that's basically like its confidence. So 1 is 100% confidence to jump. 0.5 is a 0% confidence to jump or not jump. So it's not confident in anything at all. It doesn't know what it's doing. You really don't want to have that. And a 0 is 100% confidence to not jump, which is also, that's really good. And what's really important to note that this threshold right here, it can be changed. So the 0.5, where it's not sure it should jump, you can change it to say, I want my bird to be 80% sure that it, at least above 80% sure that it should jump before I'll actually jump. And that makes sure that the bird is much more confident that in its should it jump or not, which you can change, which will affect the outcome of the algorithm, obviously. So that's kind of it for the slides. I'm going to give a demo real quick, but you can also find the exact files in my GitHub website in the Flappy Bird folder. So let me go to my thing real quick. Okay, so this is my my code itself. It's basically I'm using here. These are just a bunch of variables, which is actually kind of important. You want to play around with it, you can always go ahead to. But I'm just going to show you what it looks like in the first generation. So why don't we get this running? Give it a second. There we go. It's taking its time. There we go. So basically right now, these birds, you can see there's a very helpful caption. So let me slow this down real quick. So we're on generation 1, bird 2. The bird starts at 0 because 0, 1, 2, just like encoding. You could change that. But basically for each, basically the game iterates over and over in a while loop. For each iteration it stays alive, it adds a little bit of a score. And then if this passes, you can see it'll add a 10. But you can see this output value here. And this is what I was talking about with the AI output. It's constantly getting inputs from the game, predicting an output. And based on this output, it'll tell you if it jump or not. I don't know what my threshold is right now. Oh, there, it is 0.5 right now. So if it's above 0.5, it will jump if it's able to. The game actually does not allow you to jump if you're already jumping because then it's kind of broken. But let's see if any, so I'm going to unfreeze it and let's see if any birds actually do good. Okay, so this bird is already doing pretty good. So it's going to keep going. Okay, that bird got like at least 3, I think, or something. So in each population, I have 20 birds, and you can see I have 4 elites, which is kind of the parents. Sorry about that. Okay. And I have 6 mutations. So basically the mutations are the random ones. So I have 4 elite birds, which is 4 parents, 6 mutations, and that means that there would be 10 younger birds. So we're already on bird 18 here, actually. So let's let it go to 20, and then you'll kind of see something that's really cool is all these birds are different color. And basically that's, you can kind of see like a pattern appear where it'll pass on its color. So you can kind of see which parents are selected. And what's really cool is that over time, there'll be more convergence on one color because then all the parents will create those kind of offspring. So it passes down its color, mixed with another parent's color to create the child, which I think is pretty cool. But okay, this guy's actually doing pretty good. He's got, so I'm going to kill him just for the sake of time. And yeah, let's let this guy go for a bit because maybe, okay, there we go. Now we're on the second generation. Now you're going to start to see there's a bunch of birds which kind of like somewhat similar like colors. Okay, these are pretty trash. But basically that is because the parents have combined, which means that it creates this sort of color. So this bird is already doing pretty good. Let me speed it up here. Let's let it keep going. But basically, yeah, this is kind of what you would expect. So I've seen in certain test runs, this high score here was 241, which shoots past like probably 24 pipes. But I've seen birds that can go beyond like 5,000, 50,000. So, I mean, at one point it's really like unbeatable in the game. So yeah, I think this bird's already going to beat that. But yeah, so, and then just for the sake of it, I kind of wanted to show it just for fun. If I just fast forward to like the 20th generation or whatever, and we let it run, we'll kind of get an updates here. So the best bird in this one was actually 4,300 and 8,400. And this one's already taking some time, so it's already going to be, yeah, this is, I don't even know if we're going to get to see it at this point, actually. Because I have a max score cap here, but you can kind of see how good it is. Yeah, so it's already hit the max score cap of 50K, which means that it automatically dies because we kind of don't want it to go forever and kill the computer. But yeah, this has already hit 5,000 pipes, that means, by the way, which is pretty interesting. Let me, actually, let me just go to generation like 5. You can see each genetic algorithm is going to have a different output. Okay. So, oh god, yeah, these birds are pretty good. So, yeah, We can actually wait for this one because I kind of want to see how good they become. But anyways, yeah. If there's any more projects like this, or if anyone wants to like play with this, or like change some values, or change any of the code or anything like that, then you can always find it on my GitHub, as well as some future ideas for this project would be probably to try to do some kind of supervised learning or some Q learning, which is something I've not really dived into, but I'm kind of interested in that. And then also all of this right now is straight code. So probably putting it into a different IDE where it'll probably process better. It's probably a good idea. And then finally, last but not least, saving the process, saving the brains of the birds. You can just write it to like a txt file or something. You can say like kind of get a high score and get some really strong birds, but most of these birds could probably go forever at this point. So yeah, as you can see, I mean, yeah, this is kind of self-explanatory as to how good some of these birds can get. But so hopefully we'll get to see it soon. Oh, here we go. All right, so this bird is probably going to be kind of cracked. Let's be real. But one thing I do want to show you is I'm going to kill it automatically, which is just a keyboard function that I have. And you can kind of see they're all going to be the same color, which I think is super cool. And that's just kind of showing you how the parents pass down their genes to the younger, to the next generation, and have similar colors. So this guy's also kind of just like light blue color. I think it's pretty cool. Let's slow it down. You can see his outputs. Yeah. So let's speed it up. All right, let's just kill him. Let's see what other colors there are. Yeah, this guy's also. So yeah, if you really want to, this guy's new. So there's probably some pink guy in there as well. So if you really want to see more stuff like this, yeah, just like I said, go ahead, check out my GitHub. And yeah, thank you so much for listening to this presentation.